So now that we've seen how to do a composition in terms of numbers, we're going to come back to our warm-up to talk for a second about how do we do a composition of one function into another function. All right, so taking a look at what we have here, this is the same as saying f of g of x if we say that g of x is equal to 2x. All right, so the inside piece, that's the g of x. All right, so for this one, this would be f of g of x if we said that g of x was equal to x plus 2. And for this last one, this is like saying that g of x is equal to x squared. So what we did in our 3 warm-up problems is exactly the same as finding f of g of x. We just didn't specifically identify what the g of x was. So what we're going to do is we're going to take a look at 3 separate functions and we're going to try a few different compositions. All right, so here we go. Use the functions below to find each composition. All right, so we've got f of x equals x squared plus 2x minus 3. We have g of x is 2x plus 1, and h of x is 3 minus x. And we're going to find these 3 separate compositions. Okay, so here we go. On this first one, this is the same thing as saying find g of h of x. And I tend to switch to this notation just because it's a little bit more familiar and sometimes easier to follow, but you need to be comfortable with both notations. All right, so that means I'm doing g of h of x is right here, 3 minus x. So I'm doing g of 3 minus x. And I tend to write that down to remind myself, hey, this is what I'm going to plug in. Now I've got to figure out what am I plugging it into. So it's getting plugged into this expression right here, 2x plus 1. So that's going to be 2x plus 1. In place of the x, I put the 3 minus x. And now I just need to simplify and I'm finished. So I have, no, not 2, Miss Mara. This is a 6 minus 2x plus 1, which comes out to 7 minus 2x, or negative 2x plus 7 if you prefer. Either one is fine. This is the result for g of h of x. Okay, so give h of f of x a try. Pause the video, give number 5 a try, and if you're feeling ambitious, give number 6 a try. Then put the video back on to make sure you did it right. All right, here we go. For h of f of x, means I'm doing h of f of x is the x squared plus 2x minus 3. And I'm plugging that into h of x, which is over here, so 3 minus x. Okay, so 3 minus x, but x is now the trinomial, x squared plus 2x minus 3. So distribute the subtraction sign. And combine like terms. I'm going to write this one in standard form, but again, the order of your terms is not super important with these. The most important thing is that you have the correct terms. Okay, so there's number 5. Negative x squared minus 2x plus 6. Remember, you're not trying to factor or anything like that. This is actually a prime quadratic. It doesn't factor at all. But factoring is not something that you're concerned with here. Standard form answers are best. All right, problem number 6. F of h of x. So that one's already written in that notation. So I just want to note that this is the same as f of h of x is the other way that this could have been presented to you. But we're going to dive right into this as f of h of x is 3 minus x. So what I need to do here is I need to plug that into the f of x expression that I see up here. All right, so that's going to be x squared plus 2x minus 3, and I need to fill in a 3 minus x in each set of parentheses. All right. Now this one's going to be more involved for simplifying because I have to FOIL right here. I have to distribute right there. Okay, so there's a lot more algebra to do here, but it's still stuff that you guys are very comfortable with. So this is going to give me 9 minus 6x plus x squared, and then a plus 6 minus 2x, and a minus 3. And then I want to combine all of those terms to get my standard form answer. So let's see, I'm going to have 1x squared Let's see, negative 6x minus 2x is minus 8x. And then I've got 9 plus 6 is 15. 15 minus 3 is 12. All right. And again, you don't need to worry about factoring or anything like that. This one does in fact factor, but it's not necessary to do that. All right. I have one final question for you, and it's a true or false. So, true or false? For all functions f of x and g of x, f of g of x equals g of f of x. So I want you to think about that for a minute. All right? This is saying that the composition in one order is the same as the composition in another order, and that's going to be true for all functions. So does that seem plausible here? All right. Now let me go back for a moment. Take a look at number 5 and 6. Number 5, we have h of f of x. Number 6, we have f of h of x. So that's actually the scenario we're talking about right here. Same two functions composed in the opposite way. All right. Are these two functions the same? And clearly they are not. Yes, they're both quadratics, but they're very different quadratics. So this is a counterexample right here. So when I scroll back down, this is a big fat false. Okay, so I'm going to write that examples 5 and 6 are a counterexample proving that this statement is false. Oops, I can spell, I swear. So this is false. Now, there are going to be some situations where this statement is true, and that's what we're going to talk about next week. All right, so part 2 of this is going to be about what are called inverses, and that is the special case where this statement will be true. All right, but that's what we have coming up. All right, good luck with your homework. Let me know if you have any questions.